Hey guys, we are kicking off this new unit and we are diving into what are called rational expressions. So as we get going, we got to have that phrase kind of tucked in the back of our mind because that is what this unit is all about. And so rational expressions, definitely going to define that. We are going to talk through what makes a value excluded because there are some rational expressions that don't have x's that don't work. And then we're going to do some simplifying. That's our goals for this morning or afternoon, whatever. I guess they're goals for this video. Maybe it's a better way to say it. So first of all, we got to do some defining. A rational expression is a fraction. So that's the word ratio, meaning fraction, and it's a fraction made up of two polynomials. So if we want to see a quick example, it would look something like this. X squared plus 10x plus 21. That is a polynomial, and that will live in our numerator over another polynomial, x plus 7, in our denominator. Okay, so that's what we're talking about. We're talking about rational expressions. We're going to see lots of fractions in this unit, and I promise you'll be okay. We'll take good care of you. In these fractions, there are things called excluded values. We got to talk about what an excluded value is. So for us, excluded value is always tied to the denominator. And any number that makes the denominator equal 0 if you plug it in is going to be considered an excluded value because we do not want to have 0 in the denominator. So if I look at the example we kicked things off with, the very first one we had up on our paper, or the one that you can see in red, that denominator is x plus 7. So the denominator is x plus 7. And since x lies, our excluded value is negative 7. Now, a lot of times you'll see it written with that slash. All that means is that we all that change is that we just are showing that it's not equal. So that's what makes it excluded, is the fact that we can't have x be negative 7 because it sets off a whole host of problems. As we go into simplifying these, kind of 3 steps that I want you thinking through. The first step is we're going to do some factoring. Really factor anything that needs factoring, but for sure factor the numerator and factor the denominator. Now, if you have forgotten how to factor, there is a video on how to factor, also linked in your learner's guide, but you can also probably Google some and find some there too. The next thing, step 2, identify any excluded values. We have to identify anything that's excluded before we can get going too far with step 3. And step 3 says that finally we get to carefully cancel any common factors. In other words, we can cancel anything where the stuff in the parentheses is the same in the numerator as in the denominator. Those are our 3 steps. So let's look at some examples. We'll slide down here, and we are actually going to, you're going to notice it's kind of a theme with some of these notes. We're going to skip this first one. Doesn't really fit our jam, and we're not going to worry too much about it. Instead, we're going to dive into the second one. So step 1, factor. So X method factoring, we're going to use a lot. In the top, we've got negative 64, and we've got 0. And so this is a weird one, but we're going to get a plus 8 and a minus 8. We haven't done too many with 0 in there, but that's how that one fits. In the bottom, we've got 16 and 10. Both are positive, which means our sides are positive, plus 8 and plus 2. So when I think about this, I'm going to rewrite it with these factorings. I'm going to write x plus 8, and I'm going to write x minus 8. And then in the denominator, I'm going to write x plus 8 and x plus 2. And hopefully your brain is triggering you a little bit, saying, hey, look, something's going to cancel. 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 The problem is we can't cancel it yet because step 2 is those excluded values that we've been talking about. Whoa, that's awkward. How did I lose it? Okay, I'll try that. I'll try that again. My bad, guys. So we are looking for the excluded values in this part of the problem. So in our denominator here, I see an x plus 8, but I remember that x lies, so I'm going to write it as x cannot be a negative 8. And then I also see an x plus 2, but I remember x lies, so I'm going to change it so x cannot be negative 2. Okay, those are my excluded values, and they come right out of the denominator. I don't touch the numerator. And now I get to do the fun part. Now I get to carefully cancel. So I see a pocket of parentheses with an x plus 8 and a pocket of parentheses with an x plus 8, and those cancel each other out. And so now my rational expression has simplified like so. There's our final answer. So we would say, here's our answer, and then we would say, here's our excluded values, which are also part of the answer. Awesome, awesome. Again, if you're not sure how to factor, watch that video. Otherwise, I think you guys are going to do great things.